We talked about differences between narrative reviews, systematic reviews, and meta-analysis. We also looked at forest plots to interpret the results of meta-analysis. Now, let's visually assess the variability of the body of studies in a meta-analysis, which is the course learning outcome number 4 on the course syllabus. When answering a question in a meta-analysis, there are so many variabilities. There are a broad range of patients, interventions, ways of measuring outcomes, and these are all important in order to avoid false effects from subgroup analysis, and they lead to narrow confidence intervals and increase applicability across a broad range of patients. However, in meta-analysis, there is an underlying assumption that across the range of study patients, interventions, and outcomes included in the analysis, the effect of interest is more or less the same. So if there's too much variability, this assumption will be violated. The solution to this dilemma is to evaluate the extent to which results differ from study to study. And we call this difference from study to study as variability or heterogeneity. And of course, this heterogeneity can be from population that are enrolled in the studies, from the interventions they had, from comparators they had, and of course, based on the methods that they use in every study. As you know by now, the results of a meta-analysis will be displayed in a forest plot. We can actually look at the forest plot to look for inconsistency or heterogeneity of the point estimates in the different studies, and that way we can visually assess for variability or heterogeneity. In other words, when we visually assess for heterogeneity, we're eyeballing the forest plot. The question is whether the heterogeneity is sufficiently great to make us uncomfortable with combining results from a group of related studies to generate a single summary effect. Now, generally speaking, we are comfortable with the single summary effect when all studies suggest benefit or all studies suggest harm. In other words, if all studies are in agreement, then we are comfortable combining the studies. Another thing to look for is the magnitude of the difference between the point estimates of the studies. So a large difference in point estimates should make us less confident in the pooled estimate, and vice versa. And lastly, we would want the confidence intervals to overlap widely, because when they don't overlap, random error becomes an unlikely explanation for differences in apparent treatment effect across studies. Let's take a look. So here on the example to the left, you can see that there are 4 studies listed. The first 2 studies are actually in favor of treatment, so they are on the left side of the line of no difference. And the third and the fourth study are actually in favor of the control, so they are on the right side of the line of no difference. Now all 4 studies are statistically significant. So they actually combined all 4 studies and they found that overall the results were in favor of the treatment. Now, when we look at for heterogeneity, of course, we can see that the point difference between the first 2 and the second 2 are hugely different. So there's great heterogeneity. And not only that, not only the point estimates are different, the confidence interval also don't overlap. Although the first 2 studies, they agree with each other, so there's overlap between the first and the second one, and the point estimates are similar. But when you compare the third and the fourth one to the first and the second one, not only do they not, there's no overlap, and the point estimates are different. Now, of course, the third and the fourth one are similar to each other, but you want all 4 of them to overlap and also to have the point estimates close to each other. So there's a lot of, so visually I can say that there's a lot of heterogeneity in this meta-analysis. In the second example, you can see that all point estimates are close to each other and there's significant overlap with the confidence intervals. So although all 4 studies, none of them reached statistical significance, when they combined all 4, the results were statistically significant in favor of the treatment, and there was minimal heterogeneity. In other words, I can actually say that when visually assessing this, I can call this a homogeneous meta-analysis. And then the last example on the right, it also shows you 4 studies. Of course, they disagree. So one, you can see 2 of them are on the left side of the line of no difference, and 2 of them are on the right. So the point difference are different, but there's a good amount of overlap with the confidence intervals, and the point estimates, although they are different, they're closer to each other, so they're not too far from each other. So there's some heterogeneity, but not too much. And when they combined it, they did not find statistically significant results, because the overall aggregate results includes the line of no difference.